Hello dear student, welcome to new session of Laws of Motion. It's your 15th lecture. In Laws of Motion we are discussing about friction, and in last class we'll discuss about motion on a horizontal circular track with constant velocity. We'll discuss the topic in last class, that how in horizontal circular track, if velocity is constant, then what basically the value of velocity with which the particle is moving. Now we'll discuss motion on a horizontal circular track with variable velocity. Now the velocity is variable. So if velocity is variable, so if, my dear student, if velocity is variable, it means the magnitude of velocity is changing. The magnitude of velocity is changing. The magnitude of velocity is changing as the velocity is, dear student, variable. So see, my dear student, as we know, if the particle is in circular motion, let's suppose the radius of circle is r, then the particle carry two different acceleration. One is tangential acceleration and another is centripetal acceleration. In circular motion we already discussed that both the acceleration works different. Tangential acceleration changes the magnitude of velocity and centripetal acceleration changes the direction of velocity when the particle is in circular motion. So my dear student, in last case we'll discuss about if velocity is constant. So if velocity is constant, then we know that the magnitude of velocity is not changing. But in this case, velocity is variable. So if velocity is variable, it implies that the magnitude of velocity in this case is changing. So if velocity magnitude is changing, it means the tangential acceleration is working. It means in this situation we will introduce tangential acceleration as well along with centripetal acceleration, because we know that centripetal acceleration always acts if the particle is in circular motion, because centripetal acceleration works as changes the direction of velocity. And if the particle is in circular motion, then it is but obvious that on each point in circular track the direction of velocity is different. So when the particle is in circular motion, then it is mandatory that centripetal acceleration always acts, but tangential acceleration is not mandatory. Tangential acceleration only acts if the magnitude of velocity is changing. So in this case, my dear student, the magnitude of velocity is changing because here we are considering velocity is variable. So if velocity is variable, it means the magnitude of velocity is changing, which implies tangential acceleration is also acting. So in this case, my dear student, two acceleration will act. One is towards center called centripetal acceleration and another is towards tangent called tangential acceleration. One acceleration is acting towards tangent called tangential acceleration. Why tangential acceleration is acting? Because here velocity is variable, and in circular motion if velocity is variable, then it means tangential acceleration is also acts on the particle. So see, my dear student, here two accelerations are acting. One is tangential acceleration and another is centripetal acceleration. Centripetal acceleration acts towards center and tangential acceleration acts towards tangent. So see, actually in this situation, from the common point, two accelerations are acting in two different directions. One acceleration is acting towards tangent and another acceleration is acting towards center, that is centripetal acceleration and tangential acceleration. Centripetal acceleration, we know that it is v square by r, and if I am talking about tangential acceleration, it is nothing but r alpha. So we no need to write the value of tangential acceleration because the value of tangential acceleration here is not required. So if I am making this diagram, it will look like this. We have a vehicle whose mass, let's suppose, is m, vertically downward mg, in upward direction there is a force called normal reaction force, because we know that every action there is equal and opposite reaction. If block, or we can say if vehicle apply weight in earth, then earth can also apply a force on vehicle in upward direction, that is normal reaction force. And two accelerations is acting, one is tangential acceleration and another is centripetal acceleration. And we know that both the acceleration is acting from common point, my dear student. So if two vectors are executing in two different directions from common point, then we know that we have to make its net. So we have to make the net acceleration, and net acceleration is always act between the center of two acceleration. So here, my dear student, we have the direction of net acceleration. Remember, if from a common point in two different directions vectors are executing, then in that situation we have to make resultant vector, and resultant vector always acts between the two vectors. So here it is a tangential acceleration, here it is centripetal acceleration. Between them we have to make a resultant acceleration, that is a net. And we know that the formula of finding net acceleration must be under root AC square plus AT square. So instead of AC we can write V square by R. So it is V square by R and its square plus, my dear student, AT square. So this is the value of net acceleration, and the direction of net acceleration is always between the tangential acceleration and centripetal acceleration. Now moving forward, my dear student, as we know that if the particle is moving in circular track, then one acceleration is acting towards center and another acceleration is acting towards tangent if velocity is variable. And if velocity is constant, then the value of tangential acceleration is 0. In that situation, only one acceleration is acting, that is centripetal acceleration, which acts towards center. And in that situation, as I already tell you, my dear student, if the particle is in horizontal circular track, then the force which takes place between the tire of the vehicle and the surface is friction. Due to the friction, body is capable to turn. So write down, due to friction, the vehicle is capable, due to friction, the vehicle is capable, due to friction, the vehicle is capable to make turn in horizontal circular track, to make turn in horizontal circular track. Now see, my dear student, we have one tangential acceleration, one centripetal acceleration. Between them will make resultant acceleration or net acceleration. So the direction of net acceleration is in this side. So friction, force of friction is always towards the direction of acceleration. So friction is also acts towards the direction of net acceleration. Remember, the force is always acts towards the direction of, my dear student, acceleration. So here acceleration is in this side, so friction is also acts in this side. And we know that if the motion is normal, then the part of tire which comes in contact with the road comes at rest. Hence, in normal moving of car, the nature of friction between road and tire is always static friction. Now see, my dear student, as we know, F net is equals to ma net. So here F net is friction, it is equals to ma net. So we can write friction is equals to m into under root v raised power 4 by r square plus AT square. This is the equation of force, because here the direction of, we are talking about net acceleration here because we have two accelerations in two different directions, my dear student. So the force is force of friction which takes place when the vehicle is turning on horizontal circular track. These things are discussed in previous class. So instead of force we can write friction, and remember, nature of friction is my dear student, static, because the vehicle is moving normal. If vehicle is skidding, then the nature of friction is kinetic, because kinetic friction takes place when body is performing motion with respect to the surface. Here the vehicle is moving normal, that's why the nature of friction is static. So we know that about static friction, it is always less than and equal to limiting friction. And for limiting friction, we know that limiting friction is nothing but mu s into n, and instead of n we can write, my dear student, mg. So static friction is less than, remember this friction is nothing but static friction which provide acceleration. So static friction is nothing but less than equal to limiting friction, and instead of static friction we can write m into under root v raised power 4 by r square plus at square, which is less than or equal to limiting friction. Now we'll put the value of limiting friction. So what we'll get, instead of limiting friction we can write mu into n, and n must be equal to mg. So now we'll write m into under root v raised power 4 by r square plus tangential acceleration square, which is less than or equal to mu s into n, and instead of n we can write mg. So m into under root v raised power 4 by r square plus at square, which is less than or equal to mu s into mg. Now see, m and m get cancelled, so we'll get v raised power 4 by r square plus at square, which is less than equal to mu s into g. We know that mu s is coefficient of static friction. Now my dear student, I am squaring both sides. So squaring both sides, after squaring root get cancelled, in this side it will be square. So v raised power 4 by r square plus at square is always less than or equal to mu square g square. Now I am taking at this side, so it is v raised power 4 by r square plus at square must be less than or equal to, at is taking this side, so less than equal to mu square g square minus at square. Now take r square this side, so what we'll get? We'll get, my dear student, v raised power 4 is less than or equal to, I am taking r square this side, so r square mu square g square minus at square. So v must be less than equal to under root, v must be less than or equal to r square mu square g square minus t square whole to the power 1 by 4. So this is the value of velocity with which, if particle moves in horizontal circular track with variable velocity, and if velocity of particle is less than or equal to r square mu square g square minus at square raised to the power 1 by 4, then the particle is capable to make turn in this horizontal circular track. My dear student, if the velocity of vehicle is greater than this value, and particle, or we can say vehicle, is moving with variable velocity, then vehicle cannot capable to turn. It falls down. So see, this is the velocity with which, if vehicle is moving in horizontal circular track with variable velocity, then capable to, my dear student, take turn. Otherwise, if the value of velocity is greater than this value, then vehicle cannot make turn, vehicle fall downs. So this is all about motion on a horizontal circular track with variable velocity. That's why we can say friction is sometime helping force. Here friction is the force, my dear student, due to which your car, your bike, your cycle is capable to rotate on the horizontal circular track. So I hope you all understand this part of friction as well. Now very important part and very practical concept, that is banking of road. So write down banking of road. Banking of road means to open a bank near the road. No, Banking of road means not like to open a bank on road. Banking of road is something different. See my dear student, what actually banking is and what is basically banking of road is. This is very practical application. Very practical application. Banking of road is very practical application, dear students. So I am writing here banking of road. Banking of road means if you are aware with, if you will travel on any highways, either it is national highway or state highway, you will see this thing. In some places, if turns are very sharp, my dear student, in that turn, one end of the turn is, flapped. It is will be look like this. Actually, if you see, very by making very, aware eyes, then you will see that in sharp turn of the road will be lifted from one side. Lifting of one side from the turn partition of road is called banking of road. So see my dear student, basically lifting means to make inclined plane on road. To make inclined plane on road on sharp turn is called banking of road. So see, actually, let's suppose this is a horizontal circular track. This is our turn side. From here we can make turn, our vehicle can make turn. So banking means to rise up the road from the turn section from one side. Basically, if we lift the road from one side, it forms an inclined plane. So we can say making inclined plane on sharp turn on the road is called banking of road. So if you are making a sharp, this is the part where we can take a sharp turn. Our vehicle can take a sharp turn, my dear student. So rising from one end in this sharp turn is called banking, and rising up means to make an inclined plane. So like this, and in this side it is like this. So making an inclined plane on the turn section of the road is called banking of road. So write down, my dear student, making inclined plane on sharp turn. Making inclined plane on sharp turn of the road on the road is called banking of road. Is called banking of road. Making inclined plane, I am writing here, making inclined plane on the sharp turns of road is called banking of road. Making inclined plane on the sharp turns of road is called banking of road, my dear student. Basically, this is practical application. In highways, if you will find any sharp turn, and if you will see it, the sharp turn, you will feel that from one end of the sharp turn, the road is lifted. So basically, lifting of road on one end, from one end on sharp turn is called banking of road. In this topic, we will discuss why banking is to be done on sharp turn on the road. So write down another definition of banking of road. Write down another definition of banking of road. It is write down making to lift from one end of the road, lift from one end of the road on the sharp turn. On the sharp turn is called banking of road. Is called banking of road. Is called banking of road. So see my dear student, here we have to discuss two different situations, because banking is nothing but making inclined plane on turn of the road. So here we have inclined plane, here we have inclined plane, this is sharp turn which is present on road. So making inclined plane on road is called banking of road. So in case of banking of road, we'll discuss two different things. First thing, if the vehicle is slides down, and second thing, if the vehicle is slides up. So write down in banking of road, two situations is created. First, vehicle slides down. First, if vehicle slides down, case first, if vehicle slides down. So case first is if vehicle slides down, and in case second we'll discuss if vehicle slides up. So we'll discuss two different situations. Situation one is if vehicle slides down, and in situation second, if vehicle slides up. We know that, my dear student, if this is a horizontal circular track, then it is very mandatory to understand the role of friction. Here friction must be present, and we know that vehicle is moving smoothly. So if vehicle is moving smoothly without skidding, it means the nature of friction is static. So write down the friction which takes place is static friction. The friction which takes place is static friction. So here, my dear student, the nature of friction is static because the vehicle is moving without skidding. If vehicle skids, in that situation we'll say the nature of friction is kinetic, but here the vehicle is not skidding, hence the nature of friction is static. As we already discussed, the part of tire which comes in contact with road becomes at rest, and we know that if surface body is in rest condition, then the friction which takes place, or we can say the friction which is applied by surface on the body, is static friction. So in banking of road we'll discuss case first. If body tends to slides down, case first we are discussing is if body tends to slides down. See, my dear student, banking means making inclined plane. So let's suppose this is our inclined plane, which let's suppose the angle of inclination is theta, and this is our vehicle. Now see, my dear student, as we all know, this is basically inclined plane. So in inclined plane we know that this is our y-axis and this is our x-axis. Now see, if the vehicle mass is m, then its weight is vertically downward and it is always equals to mg. Similarly, in this direction normal reaction can take place. So this is normal reaction force. Now remember one more thing, my dear student. In every situation we'll make the components of weight, but when we are talking about banking of road, remember we don't need to make the rectangular component of weight. Write down in form of note. In case of banking of road, write down in form of note. In case of banking of road, we have to make components of friction and normal reaction force. Friction and normal reaction force. Friction and normal reaction force. So see my dear student, this is basically concept of banking of road, in which now we are aware that what is banking. Banking is nothing but making a inclined plane on sharp turn of the road, on the part of road, and this is our inclined plane. We know that this is normal reaction force and body is moving like this, so there must be a force, there must be an acceleration towards center. That acceleration is centripetal acceleration. We all are aware with this thing. Basically the turn was like this, so vehicle is here, must acceleration in this side, that acceleration is called centripetal acceleration. Now as I already tell you my dear student, that when we are talking about banking of road, in that situation we have to make the component of normal reaction force and friction, and we all are aware with friction, the nature of friction is static, because the vehicle is not skidding, vehicle is only moving. In case of moving between tire and road, the nature of friction is static. Remember this thing. So let's make the component of normal. So this is our normal, so this angle is also theta. Now we have to split its component with this line. Normal reaction force is making angle theta, so along this axis we know that this must be n cos theta. Second component is perpendicular to n cos theta, it is n sin theta. Moving forward, now see, friction can take place here, because we know that friction is basically surface force. Friction is applied if body is tending to slides down my dear student. In this situation, see, if body tends to slides down, so if body tends to slides down, then it is but obvious that the direction of friction is opposite to the direction of motion. So the direction of motion is downward, so nature of friction must be the direction of friction must be in upside. So remember this thing, if body tends to slides down on bank road, then the direction of friction must be opposite to direction of motion. So slides down opposite to direction of motion means friction must be in this direction. Now we'll make the component of friction. So check it out. This angle must be theta. So along with this angle, if friction making with this line, the friction is making angle theta. So along this axis, the component of friction must be F cos theta. As we all know, friction is nothing but a force, and force is a vector quantity. If any vector quantity makes angle, in that situation we have to break its component, and we know that any vector carry two components, cos and sine. So this is the component of friction, F cos theta, and second component must be perpendicular to that component, it must be F sin theta. So see, along this direction the component of friction is F sin theta, along this direction the component of force is F cos theta. Now see my dear student, this is the direction of acceleration, because the body is turning. So if body is turning, then there must be an acceleration towards center. That acceleration is called centripetal acceleration. Now see, two forces are in upward direction and one force is in downward direction. The body cannot move in this direction nor in this direction. So we can say along these directions the forces are equal. So we can write n cos theta plus F sin theta is equals to mg. N cos theta plus F sin theta is equals to mg. I hope you all understand this thing. Now we all are aware that the nature of friction is static and friction must be mu into n, and instead of n we can write, my dear student, mg. So n cos theta plus, instead of friction we can write mu n sin theta, which is equals to mg. Now n is taking common, so n comes outside, it is equals to, no need to write, instead of n no need to write mg. So n are taking common, so we'll get cos theta plus mu sin theta, which is equals to mg. This is our, let's suppose, first equation. This is our first equation. Now my dear student, moving forward, now check it out. The vehicle is turning like this, so one acceleration is acting towards center. So we can write, see, in this direction one force is there, that is n sine theta, and other force is in this direction, so we'll apply F net is equals to ma net, because in this direction, my dear student, motion is taking place as the vehicle is taking turn. So if vehicle is taking turn, then there must be acceleration towards center. That acceleration is called centripetal acceleration. So net force is n sine theta minus F cos theta is equals to m into AC. So we can write n sine theta minus, instead of friction, as we know the nature of friction is static, so instead of friction we can write mu into n. So mu into n cos theta is equals to m into AC. Now again taking n common, we'll get a sine theta minus mu cos theta is equals to m into AC. Let's suppose this equation to be our equation number 2. This equation is to be equation number 2. Now we'll divide equation 2 by equation 1. So divide equation 2 by equation 1. What we'll get, my dear student? We'll get C. N sine theta minus mu cos theta is equals to m into, instead of AC we can write v square by r divided by n, and again it is cos theta plus mu sine theta is divided by mg. So mg can be write like this, n and n get cancelled, r get cancelled, sorry, m get cancelled. So what we'll get? We'll get sine theta minus mu cos theta divided by cos theta plus mu sine theta is equals to v square by rg. Now rg taking this side, so v square is equals to sine theta minus mu cos theta divided by cos theta plus mu sine theta multiply by, dear student, rg, multiply by rg. Now we can divide numerator and denominator with, my dear student, cos theta. So divide numerator and denominator by cos theta in RHS. So what we'll get? V square is equals to sine theta upon cos theta minus mu cos theta upon cos theta divided by cos theta upon cos theta plus mu sine theta upon cos theta into rg. So now see, cos theta get cancelled, cos theta get cancelled. So now see, it is v square is equals to, v square becomes equals to, v square is equals to sine theta upon cos theta is nothing but tan theta. So tan theta minus mu upon 1 plus mu sine by cos again tan and it into rg. So v is equals to under root tan theta minus mu upon 1 plus mu tan theta into, dear student, rg. This is the formula of velocity, minimum velocity. Remember, this velocity is minimum velocity required to take turn on banked road. That is minimum velocity required to make turn on banked road. It is V minimum is equals to under root tan theta minus mu upon 1 plus mu tan theta into rg. If your vehicle is moving with minimum this much velocity, then only you are capable to take turn on banked road. If your velocity is greater than this velocity, or we can say if your velocity is less than this velocity, then the vehicle will falls down. Moving forward, my dear student, we are discussing now case 2, when the body tends to slides upward. So if body tends to slides upward, in that case the nature of friction is static but the direction is downward. As simple as this, because we know that the direction of friction is always opposite to direction of motion. So write down, if body tends to slides up. Case 2 is if body tends to slides up. Remember, when the body is tends to slides down in banked road, in that situation the velocity which will get is minimum velocity, and if body tends to slides up, in that situation the velocity what we'll get is called maximum velocity, my dear students. So if your velocity is less than minimum velocity and you are running a vehicle on banked road, then also you'll falls down. So moving forward, case 2, if body tends to slides up. Write down, case 2, if body tends to slides up in banked road. If body tends to slides up in banked road. So see, my dear student, this is an inclined plane. As we know, banked road means making inclined plane. So this is a banked road. Let's suppose we have this vehicle whose mass is m, my dear student. So vertically downward, we know that a force will act, that force is mg, and in this situation we have to make the component of normal. So see, my dear student, this angle must be theta. Normal reaction is a force. So if it is a force, then it is but obvious that the force if makes angle, then we have to split its component. So in this direction we have n cos theta, in this direction we have n sin theta. Now see, dear student, the vehicle is making turn. So if vehicle is making turn like this, because this is our horizontal circular track, and vehicle is moving in this horizontal circular track, then there must be a acceleration which acts towards center, because without centripetal acceleration body is not capable to move in horizontal circular track. So centripetal acceleration must be towards center. Now the body slides up. So if body slides up, then the friction must be in downward direction, and friction is a surface force. As we all know about friction, friction is nothing but a surface force. Now see, my dear student, friction is acting like this. So if friction is acting like this, then we have to split its component. If this angle is theta, then this angle is also theta. One component of friction comes this side, that is f cos theta, because with this line friction is making angle theta, and second component must be perpendicular to that. So in this direction we have f sin theta. Remember, any vector quantity if makes angle, then we know that we have to split its component, and any vector carry two different components. One is cos theta and another must be sin theta. Now see, my dear student, in this direction motion is not possible, and remember, as the body is not skidding, it is just moving. So if a vehicle is just moving, then the nature of friction must be static. So I am writing here, nature of friction is nothing but static. Remember this thing, nature of friction is static. Now see, my dear student, along this direction motion is not possible, so we can write n cos theta is equals to mg plus f sin theta. N cos theta is equals to mg plus f sin theta. N cos theta is equals to mg plus f sin theta. Now see, the direction of acceleration is in this side, and both the forces, that is component of normal and component of friction, both are in same direction. So we can write F net is equals to ma net. So F net means f cos theta plus n sin theta is equals to m, and instead of a net we can write centripetal acceleration here, because the particle is moving so in circular track. So f cos theta plus n sin theta must be equal to mv square by dear student r, because we know that the value of centripetal acceleration is nothing but v square by r. So n cos theta. Now see, this is our first equation, and this is our second equation. This is our second equation and this is our first equation. Now I am taking f sine theta this side. This is our first equation and this is our second equation. So I am writing here from equation first, I am taking f sine theta this side. So I can write n cos theta minus f sine theta is equals to, my dear student, mg. Now we all know that friction is nothing but static. So instead of friction we can write mu into n. So I am writing here it is n cos theta minus mu n sin theta is equals to mg. I hope you all understand this concept, my dear student, as well. So n cos theta minus mu n sin theta, instead of friction I'll write mu n. So let's suppose this is equation number 3. Moving forward to equation number 2. Equation number 2 says f cos theta, I'm writing here from equation second. So it is f cos theta, that is f means mu n cos theta plus n sin theta is equals to m v square by r. Now I am taking n common, so what will get? N taking common, so mu cos theta plus sin theta is equals to mv square by r. This is another equation which forms, let's suppose this equation to be equation number 4, and now from equation number 3, so from equation 3 again I am taking n common, so what we'll get? We'll get n is taking common, so cos theta minus mu sin theta is equals to mg. Let's suppose this equation to be equation 5. Now I'll divide equation 4 by equation 5. So divide equation 4 by equation 5. What will get? N, and it is mu cos theta plus sin theta is equals to mv square by r divided by n cos theta minus mu sin theta and mg. So see, my dear student, mm get cancelled, n and n again get cancelled. So what will get? I hope you all understand. Very easy to understand, my dear student. If you are aware with the friction, FBD, then it is very easy to understand. So see, what we'll get? Mu cos theta plus sin theta divided by cos theta minus mu sin theta is equals to v square by rg. So now I am dividing numerator and denominator in RHS by cos theta. So what we'll get? Mu cos theta by cos theta plus sin theta by cos theta divided by cos theta by cos theta minus mu sin theta by cos theta is equals to v square by rg. So cos theta get cancelled, cos theta get cancelled, mu plus sin by cos, it is tan theta divided by 1 minus mu sin by cos, again it is tan theta. So tan theta, next is v square by rg. It is v square by rg. So what we'll get? Taking rg this side, so v square is equals to rg mu plus tan theta divided by 1 minus mu tan theta. So v becomes equals to under root rg mu plus tan theta divided by 1 minus mu tan theta. And remember, my dear student, this velocity is maximum velocity. When the body tends to slides up, then that velocity with which the body is moving on banked road, that velocity is called, my dear student, maximum velocity. So what we'll get? If your velocity is greater than this velocity on banked road, then you will falls down. If your velocity is less than minimum velocity on banked road, then also you will get falls down. So this is all about, my dear student, banking of road. I hope you all are understanding, you all are making proper notes. In next class, we'll discuss some more topics related to friction. We are very close to complete this chapter. After completion, we'll discuss some numericals related to JEE and NEET Try to practice the numericals by your own with your notes, or we can say in reference books. Till then, thank you so much my dear student. Take care. We'll meet on next class with next topic. This is maximum, and in previous part we'll discuss minimum velocity. So thank you so much my dear student.